Over half of documentation traffic today doesn't come from human engineers. It comes from autonomous AI search bots constantly scraping for context. Most documentation sites are built entirely for those human engineers. They rely on nested HTML structures, visual user interfaces, and complex navigational menus that make reading easier for people. When an AI agent attempts to read these human-optimized sites, that helpful visual architecture turns into a labyrinth. Bots struggle to separate the actual technical content from the surrounding UI clutter. This is a grep loop. As an AI crawler moves down a hierarchy, it hits recurring links and is forced back to the top node, trapped in a recursive cycle. Every loop guarantees retrieval failures, hammering the server with massive, expensive HTTP requests. To solve this, technical communicators have to stop feeding HTML to autonomous agents. We need to deploy semantic plain text standards that bypass the visual UI entirely. This requires adding two specific files to your documentation architecture, the llms.txt and llms-full.txt standards. When documentation ignores these machine-readable formats, the resulting retrieval failures and high latency prevent AI tools from accurately serving that data to the developers who need it. Building AI-optimized documentation requires splitting the ingestion process into two distinct mechanical phases, discovering where the information lives and actually reading it. This matrix breaks down their division of labor. Left, llms.txt is a strict navigational map of paths and summaries for rapid discovery. Right, llms-full.txt concatenates your documentation into a Markdown document for single query ingestion. The map must be small, while the full text is inherently massive. By separating navigation from the actual reading process, you prevent AI tools from burning expensive compute cycles trying to map a site they can simply download in bulk. To implement this architecture, the first rule of deployment is placement. Both plain text files must be hosted at the absolute root of your site's domain so agents can reliably find them. Looking at a standard llms.txt layout, you'll notice it relies entirely on plain text Markdown. There are no complex markup structures, just direct, readable text blocks and links. Below the headers, every core documentation link is paired with a specific contextual summary of what that page contains. These summaries are mandatory engineering requirements. They enable an AI model to evaluate the relevance of a specific path instantly, identifying the correct document without needing to fetch and parse the file itself. This visual represents the primary constraint, a 50,000 character limit. If exceeded, the AI abruptly truncates the file, guaranteeing retrieval failures. The workaround is using subindices. By nesting heavy directories into secondary text files, the primary root stays safely under the limit. Adhering strictly to this character budget guarantees that an external crawler can map the entire logical structure of your product without running out of memory. While the root map is tightly constrained, engineering the llms-full.txt file requires a completely different approach to sanitation. The goal here is to eliminate the need for dozens of individual API calls. Instead, we want to deliver the entire documentation landscape to a downstream model in a single, massive payload. But if you simply concatenate your existing Markdown files together into a giant text block, you will break the AI's ability to cross-reference your data. Looking at the raw Markdown, the first cleanup mandate targets internal navigation. Every relative link must be programmatically converted into an absolute URL. External AI agents lack local context. Without absolute URLs, they have no way to accurately resolve cross-references. The second mandate requires enforcing strict parity between your semantic HTML and the raw Markdown feed. Technical writers must apply attributes like data markdown ignore to actively strip out UI-only elements. Copy code buttons, interactive widgets, and layout wrappers have no place in a raw text feed. The final rule of concatenation focuses on accuracy. Legacy versions and deprecated pages must be completely excluded from the consolidated file. A single query file fails at its primary job if it feeds a model broken paths and dead code. Ruthless curation is the only way to ensure accurate AI generation. The technical implementation of these files ultimately solves two major operational problems: the physical load on your servers and the financial cost of token processing. By eliminating the grep loop, redundant HTTP requests plummet and token costs mirror the decline. AI operations bill based on raw character volume. Stripping out dense HTML wrappers delivers the exact same technical information, but forces the AI to consume significantly fewer tokens. Beyond just the cost of tokens, this optimization protects the most vital resource in any AI operation, the model's context window. A context window dictates the strict physical limit on how much information a model can hold in its short-term memory during a single prompt. Feeding an AI raw web pages packed with navigation code or bloated legacy files wastes its finite, highly expensive cognitive capacity on irrelevant data. A properly sanitized llms-full.txt file guarantees that 100% of the context window is dedicated exclusively to high-value, current technical data. Optimizing your documentation solely for human-readable HTML is no longer sufficient. Modern platforms require a dual architecture strategy. Deploying semantic plain text standards is now the standard method for protecting documentation infrastructure from the costs of autonomous traffic. The llms.txt architecture transforms documentation into a high-performance AI asset, reducing server overhead while keeping data accessible to the tools building modern software.